Hi there, during this session I'm going to be talking about how to apply the wave equation, a mathematical equation which describes the relationship between frequency, wavelength and wave speed. So let's start off just recapping what we know about frequency. So frequency is the number of waves passing a point each second, and we know it's measured in hertz. So the number of waves passed divided by time taken. So 1 wave per second will give us 1 hertz. Two waves per 1 second will give us 2 hertz, and so on and so forth. So with that as our starting point, let's think about the example below. So here we have a set of waves which pass through a point in 1 second. Now what is the frequency here? So all we have to do is consider how many waves have gone through. 1 complete wave, 2 complete waves, 3 complete waves, 4 complete waves. So 4 waves per second, that means my frequency in this situation is 4 hertz. Now we're going to apply this thinking a little bit. So again, we're imagining sea waves. We're imagining a shipwreck and the waves passing across this shipwreck. The shipwreck provides us a point in time which is our reference point, which we can look at carefully. The sea waves happen to have a wavelength of 2 meters from trough to trough or from peak to peak. Now, sitting there watching this waves go past over this shipwreck, 1 second later I can gauge how many waves have gone past. So this time I'm going to count my waves back. I've got 1 complete wave, 2 complete waves, 3 complete waves, 4 complete waves, 5 complete waves. So that means it's 5 waves passed per second. So that's the frequency. Now let's break this down a little bit and think about the wave speed. If there's 5 waves passing per second and each wave is 2 meters long, that means my wave, or 5 waves each 2 meters long, means there's 10 meters of distance travelled in 1 second. So the speed is 10 meters per second. This example lets me think about frequency multiplied by wavelength equals the speed. Now this is the basis of the simple wave equation. The wave equation relates wave speed in meters per second equals frequency times wavelength. Now don't forget, frequency is measured in hertz, but it's per second. Okay, so unit wise this still works quite happily. And for those of you who have to, you can think about it rearranging it into a simple triangle. So you're just covering the unknown to work that out. So this is the wave equation. This links together frequency and wavelength with the speed of the wave. It's fairly straightforward. Let's try and put it to use a couple of times. So I'm going to ask you just to pause for a moment and do some basic calculations to work out each one of the unknowns in this table. So I'm going to pause. Now that should hopefully have given you enough time to answer all those questions if you are pausing the video as well. Let's see how well you did. First of all, my water wave. The speed of this water wave is going to be 3 meters per second. My Mexican wave, travelling around a stadium, the frequency is going to be 0.2 waves per second. My musical note is going to be 1.32 is the wavelength. My rope being flicked up and down is going to have a speed of 2.4 meters per second. And finally, ultrasound will have a wavelength of 0.01 meters. So these are some examples of the type of questions you're going to get. I'm going to show you just 4 more, a little bit more challenging questions. Again, we're always going back to that simple relationship. So here are 4 questions. What I'm going to do is, again, I'm going to hopefully that you're going to press the pause button now. And now you've had a chance to try these 4 questions. We can just quickly go through the answers. For question number 1, the waves are going to be 0.2 meters apart. That means that's going to be their wavelength. Question number 2, the wavelength is going to be 0.5 meters. For question number 3, the speed of light is going to be 3 times 10 to the 8 meters per second, something you possibly should already know as being a constant. And then finally, the wavelength, so the frequency which we work out is 7.5 times 10 to the 14 hertz. So fairly straightforward, but that is the wave equation. You're going to have to do some calculations with that, I'm quite sure, and it's also linked in with lots of things. That's everything you need to know about it for now.